Okay, so as you sit in your living room, there's lots of different waves going through you. So, for example, from the sun, from the appliances around your house, from the rock and the building itself. These waves are called electromagnetic waves. So, electromagnetic waves, or in short, we call them EM waves, have many different uses. But let's look at what they actually are. We've seen that a lot of waves are made from particles oscillating. However, electromagnetic waves are not made from particles oscillating. Electromagnetic waves are made from electric field oscillating and a magnetic field oscillating. This is why we call it an electromagnetic wave. Electric field and magnetic field. Now they have a lot of things in common, these electromagnetic waves. So first of all, they all transfer energy, all these different types of electromagnetic waves. They're all transverse waves, and they all can travel through empty space. They can travel through vacuum. Here are the different types of electromagnetic waves in one diagram. On the left, we've got the longest wavelength one, and the right, we've got the shortest wavelength. Now, long wavelength also means low frequency, while short wavelength means high frequency. High frequency basically means there's lots of waves in 1 unit of time, in 1 second. Okay, let's look at the different types of waves in this diagram. So we've got on the left hand side, we've got radio waves, which has got the longest wavelength, then microwaves, then infrared, then visible light. Now that's the light that we can see, and that can be further broken down all the way from red on the left hand side to violet on the right hand side. And then after violet, we've got ultraviolet, and then we've got X-rays and gamma rays. Okay, so radio waves have the least energy, while gamma rays have the highest and most energy. These all have something in common, that they all travel at the same speed in vacuum, which means empty space, and air. Okay, so they all travel at 300 million meters per second, which is the fastest thing in the universe. So this is a lot to remember, so we need to get the order correct. So I'm going to give you a mnemonic to help you remember the order. The mnemonic is raging Martians invade Venus using X-ray guns. So imagine this Martian here with an X-ray gun, it's invading Venus. Okay, so what does R stand for? Radio waves. M for microwaves. I for infrared. V for visible light. U for ultraviolet. X for X-rays. And G for gamma. Okay. And so if you remember this mnemonic, you just say it out loud a lot and often, then it will help you remember the order from the longest wavelength to the shortest. Okay, but if you also remember the order of the colors, so all the way from red, orange, yellow, green, blue, indigo, violet, then there's another trick to remembering these. So think of a person whose name is Roy, first name is Roy, middle name is G, okay, and his last name is Biv. So Roy G Biv. Okay, so R for red, O for orange, Y for yellow, G green, blue, indigo, violet, and so on. Okay, first question here, we're going to complete the gaps to show the order of the electromagnetic spectrum, okay, from the longest to shortest wavelength. So I'm going to use my mnemonic. I'm going to use raging Martians invade Venus using X-ray guns. So what does R stand for? That's radio waves. Okay, and then V is visible light. That's the light that we can see. And finally, you got G at the end. That's going to be gamma waves. Okay, last example, compare microwaves and ultraviolet. Okay, so if it's a compare question, we should normally give similarities and differences. Now, microwaves and ultraviolet, they're both electromagnetic waves. That means they're both transverse. That means they both transfer energy, and they both travel at the same speed in vacuum and air. So they travel at 300 million meters per second. Okay, what's the difference? So ultraviolet is on the right-hand side of the spectrum. That means short wavelength. And ultraviolet is high frequency as well, and ultraviolet is high energy.